Hey, what's up everybody? I'd like to welcome you to another JUCE tutorial. And in this tutorial, we're going to create a simple playhead that will give the user a visual indication of where they are in a sound as it's playing. So if you've ever used any sort of DAW, you know what a playhead is. It's just a line that goes across the sound as it's playing. And we're going to show you how to create a very simple version of this. So just to show you an example of what you're going to end up with once you finish this tutorial, we have our sampler that we've been working on. And what we're going to do is when we play a sound, we see that we now have a playhead and visual feedback of where the sound is actually playing at. So let's grab a longer sound and let's play that. We see that we have a white line that shows where in the sound we are, and it also has a little shade for showing where the audio has already been played. If you're enjoying tutorials like this and you'd like to see more of them, you can support The Audio Programmer on patreon.com/The Audio Programmer. Also be sure to join our developer community on theaudioprogrammer.com/community. Also, if you're enjoying this content, be sure to give this video a thumbs up and subscribe if you haven't already, and let's get started. So here we are in our plugin, in the plugin processor where our real-time audio is happening. We're in our process block, and that's where our audio loop is happening. And we need to ask the question, what sort of information do we need to be able to move a playhead? A playhead is actually just a line, and we're just taking it and we're moving it across the screen. Well, the first thing that we need to think about is how can we determine when a note is actually being played? Well, one way we could do this is by iterating through the Midi buffer. So the Midi buffer contains all Midi events that are happening from any Midi controllers that are connected to our computer. If you recall a earlier tutorial that I created with Eyal Amir from X4 Records, we actually created a very simple Midi plugin, and there was a specific pattern that we needed to use to actually get the information from the Midi buffer. So this is a bit confusing, but it's one of these things that you memorize over time. So just memorize this piece of code basically. So first thing we're going to do is we're going to create a Midi message, and we'll just call this M. And this is where we're going to actually store any sort of Midi messages that are happening in our Midi buffer. Next thing that we need to do is we need to create a Midi buffer iterator, and that's going to go through all of the events that are happening in our Midi buffer, and we're going to pull out those messages. So we have this Midi buffer, and then it's called Midi buffer iterator, and I'll call this IT. And what we need to do is we need to give it an argument where we put the Midi buffer, because it needs to know which buffer we're actually iterating over. So there we have that. And now we have this pattern once again. It's one of those things that you just learn over time, and it's a while loop, and we say while the iterator is getting the next event. And then we have these two arguments we need to put in here. And these are just where the Midi event information is going to be stored. So we have the result. So that's the result of what's happening in the Midi buffer. And here we could just put M, which is our Midi message. And then it has the sample position of where the event actually happened. So I'm just going to create a little int called sample, and I'm just going to put it there. So these are just two local variables that I created where I'm actually going to store any events that are happening in the Midi buffer. Next thing that we need to do is we need to actually figure out when a note is actually being hit. So luckily we could do that. If we go to our Midi message class, we could determine when a note is actually turned on by using this Boolean that says is node on. So it will basically listen, or it'll look through this Midi buffer iterator, and it'll say, have we got any node on events? And it will return true if it does. And then we also have this other one called is node off. So we get two separate messages for every kind of press and release. We get one message when it's pressed, and then another message when it's actually released. Okay, so we can say if, and then we got M, which is our temporary MIDI message, and then we could say is note on. Then what we want to do is we want to say, hey, note's on, start the playhead. Okay, and then we could say else if M is note off, and then here we would just say stop the playhead. Okay, so we're just looking through the MIDI buffer iterator and saying, okay, is there a note on event? Has a note been pressed? And then we want to listen for when the note stops being pressed and then stop the playhead there. So now what we could do is we could create something where we say, okay, if the note has been turned on, then it's true. If it's been turned off, then it's false, and stop the playhead. So I'm going to make a stood atomic Boolean M is note played. And I'll call this false to start off with. And once again, I'm making it stood atomic because what's happening is this is in our real-time loop. So this is happening in our plugin processor or on our audio thread. And what we don't want is we don't want what's called a race condition where we're trying to change whether this Boolean is true or false on one thread, and then at the same time we're trying to read whether this Boolean is true or false on the editor side. Okay, so that's the reason that we're using a stood atomic. One of the key things to understand about stood atomic is that it is a much heavier data type. So you don't want to just use this for everything. Only use it when you're using a variable that is being read or written from one thread and being read from another thread. Okay, so here we could say if a note's being pressed, then is note played is equal to true. And if the note event is off, M is note played is equal to false. I need to put an O there. There we go. So now we are fine. We can see when the note on and off events are actually happening in our MIDI buffer. Next thing we need to do is determine how long a note has been played for. So we can count this in samples. Once again, every time that we're going through a process block, this is going to go through buffer get num samples amount of audio information every time that it goes through this buffer. So what we could say is that the amount of time that we're going through the sample is going to be determined by the sample count once a note has been played. So we say when the note's been played, start a counter that's counting the number of samples that we're going through the sample, and then once it's been released, then we can turn that counter back to 0. So once again, we will create an int. We'll make sure that it's stood atomic because we're writing from one thread, reading from another thread. So this is stood atomic int M, we'll call the sample count, and we'll set it to 0 to start off. And all we'll say here is, okay, the sample count is equal to, and we want to say, okay, is a note being held down? So is a note being played? And if so, then what we want to do is we want to start counting how many samples this note has been played for. So we could just say, if a note is being played, then we can say M sample count, and we can add buffer get num samples. And what this will do is this will add the number of samples in our buffer and it will continue to add that to M sample count, and that will continue to go up and up and up until the point that we release the note. And then once we've released the note, then we want to return it back to 0. Okay, so I've written that in a shorthand way though. So let me show you how that looks if I write it in a longhand fashion. So if M is note played, then we could say sample, and I'll write this a little bit longer for you as well, just to show you just a little bit more plainly how this is happening. So M sample count equals M sample count plus buffer get num samps. Okay, so if the note is being played, then we will be adding, let's just say 512 sample values every time this goes around. We'll be adding 512 to this M sample count, okay? And then we could just say else, and then we could say M sample count is equal to 0. Okay, so this line of code 167 is the same exact thing as 169 to 176. Okay, I just wrote that shorter because it's a bit cleaner. So that's how we're going to figure out if a note's being played, and if so, how long has the note been played for in samples. Now we just need to write a couple accessor methods just so we can pass these on to our plugin editor. So we can say stud atomic bool, and we're going to make this a reference because we don't need to create a copy of this. And we could just say is note played, and we will return if this boolean is being played or not. Okay, same thing for when we're trying to get the count of how many samples this has been being played for. And we will just return M sample count. Okay, so these are the methods that we could use when we're actually painting this on the screen in our plugin editor. So now we're going to move to our UI side, where we're actually going to take these numbers and we're going to use them to actually display the playhead. So we'll go to the wave thumbnail, and now we're on our in our paint function where we're actually painting this. We're going to be painting our playhead. So at the moment we have this code that is actually drawing the waveform itself. And what we need to do is we need to think about this in a very similar way to how we did when we were actually drawing the waveform. So when we were drawing the waveform, we were saying, hey, so the waveform in samples is probably going to be a lot more than the width of our screen. And what we need to do is use a mapping function. In JUCE, we have this function called JMap, where we're actually able to make comparable a number of samples to the actual width of our screen. Okay, so we're going to do the same sort of thing for our actual playhead, where we're going to say, okay, we're going through the number of samples in our waveform, but the number of samples is obviously much greater than the width of our screen. So we have this convenient function called JMap, where we're going to say, hey, map the number of samples that are being played and map that to the width of our screen. Okay, so I'm just going to do that now, and we'll just say auto playhead position, and we will make this a mapping function. Okay, so we'll say JMap, and now we just need to say, okay, we're going to get the number of samples that are being played, which is get sample count. So we have our processor get sample count. That's how many samples have been played since we've started the MIDI note on event. And now we just need to give that a min and a max. Okay, so the min is 0, right? Because that's where the beginning of our sample is. Now the max is just going to be the number of samples that is in our audio file that we actually have in our sample. So we could do that using processor, get waveform, which gets the actual audio buffer where the waveform is actually being held. And then we just need to get the number of samples that are in that waveform. So this is just saying, hey, audio file, how many samples do I have in here? Okay, so now we're saying, okay, we got the processor, we're finding how many samples there are. Obviously, we're starting at 0. We're going through, and the most that we could have is the number of samples in the audio waveform. And now we just need to give it the width of the screen. So the minimum of the width of the screen is going to be 0, and the maximum is going to be get width, right? So this is giving us a number that's a mapped function. And what I need to do is I need to give this a template argument. So this is going to be of type int. And so what that's going to do is that's going to give me back a number that's going to be between 0 and get width. Okay, so if you're smart, then you'll be able to kind of guess what I'm going to do here, right? Because as it's going through the sample count, it's going to be increasing, right? And then what it's going to be doing is it's going to be giving me back this number between 0 and get width. And that's exactly what I could use to start drawing a line, right? So we will say, we'll set the color. So we'll say set color, and we'll set it to white. And now all we need to do is we need to draw a line and make sure that that line just moves through time as the sample count increases. Okay, so I could say draw a line. And you have a couple different ways you can draw a line here. I'm going to use the argument that gives us a line thickness. So now we need to think about where we want the line to start and where we want the line to end. So the start X, because we're moving the plate, we're going to draw a vertical line, and it's going to move to the right across the screen. It's going to move horizontally. So what we want is playhead position to be the start of X, right? Because then we're going to basically draw it at starting at 0, 0, right? So that's going to be at the top of our waveform. And then we want this to be a vertical line, so that's why we need to use playhead position again, which is going to keep us with a straight line. And then we want get height on the y-axis, right? And then the line thickness, I will just make 2, just to start off with. Okay, so that's how we're actually drawing the line that's going to be our playhead. So one thing that we need to do is we actually need to use a timer that's actually going to repaint our UI so that it actually repaints the line as it's going across the screen. Okay, we don't currently have that. And if you've seen any of my past tutorials where I'm building UIs or anything, this is something that I do quite a bit. So we need a timer that's going to basically go at a regular interval and make sure that we repaint our UI, and that will refresh where the line or the playhead is going across the screen. So we have this timer class. And then what I need to do, because I'm using a timer, let me just show you on the actual API, because I want to show people where I'm getting this from. So we have a timer class. And in here, we will see that it has a pure virtual function here. We know it's pure virtual because it says equals 0, and it's called timer callback because we need to tell it what to do when we're actually calling the timer, right? So we say void timer callback, And then once again, we're overriding this function because we're inheriting from the timer class. Now we just need to implement this very quickly. So we can say void. And once again, we're in our hello sampler audio processor editor, and we're in timer callback. And then all I need to do is I need to call the function repaint. And what that's going to do is that's going to call repaint on this component and all of its subcomponents as well, which includes our waveform, okay, our wave thumbnail. Now in the constructor for the editor, I just need to actually start the timer. So I can say start timer in hertz, and I'll just set this to 30 hertz. And then you can also stop the timer when this editor actually destructs, because you don't want the timer just to be going if you don't have the UI actually up. Okay, so that's what's happening. So so I've started this timer, and then it's going to repaint all of the components that are subcomponents of this audio processor editor. So that's how it's repainting the waveform and refreshing as the playhead is going across the screen. So let's go ahead and build this quickly and see if this is actually working. So here we are in Ableton, and now I'm just going to drag a sample in and see if the playhead is actually working. So now I'll play a note, and we see that the playhead is working now. So that's great. So let's just do a little bit more just to dress it up a little bit. And we can go back up to our wave thumbnail, and let's do that little bit of shade that we did when I demonstrated it for you at the beginning of the tutorial. So we could do a set color, and we'll do colors. We'll do black. We have this argument called with alpha where we can actually set a transparency for this. I'll just do it really light, so 0.2. So this you'll barely see the actual black. And now we will do G fill rect, and we will give it, once again, similar sort of arguments. So we're going to start at 0. We're going to start our Y at 0. Then we want our playhead position to be our width of how wide we're drawing the rectangle, and the height will be get height. So let's try that. Okay, here we are back in Ableton, and we can see that we now have that bit of transparency with that rectangle, and that's painting across the screen with the playhead. So I hope you enjoyed this tutorial. I know some parts of it might have been trickier if you were just starting out with JUCE, but I hope that I was slow enough where you could kind of keep up. And this is a learning process for me as well. So if you have any tips on how to improve this code or make it better, or if there's another way that I could approach this, I'd love to hear your thoughts in the comments, and be sure to give this a thumbs up, and I will see you next time.